Hey math kids, today we're going to talk about integrating f of ax plus b. So look like this. Cool. Alright, now we'll just jump right in. So we have 2x plus 3 raised to the 4 dx. And all we're going to do is kind of a chain rule-esque thing, but in reverse, because we're taking an antiderivative. And so we're just going to raise this to the 5, divide by the new exponent, and then we're going to divide by the derivative of the inside. And so we also put a 2 down there. And so the final answer to this is going to be 2x plus 3 quantity raised to the 5 over 10, and then don't forget your plus c. Okay, the next thing is 1 over the square root of 1 minus 3x. Okay, and we want to first rewrite this as 1 minus 3x raised to the negative 1/2. And now we're going to take the antiderivative. So when we take the antiderivative, we raise the exponent by 1, rewrite the inside, and then we want to divide by the new exponent, but dividing by 1/2 is the same as multiplying by 2. And then we need to divide by the derivative of the inside, which in this case is negative 3. And then we simplify, so we get negative 2/3, 1 minus 3x to the 1/2, and then we'll change that back into that notation, and then don't forget your plus c on the outside. Okay, we'll keep going. Alright, so we want to integrate with respect to x. So it gives us that and says integrate with respect to x. And so essentially we need to add that and that. If you want, you can put some parentheses like that. Okay, so the antiderivative of e to the x is just e to the x. So we just rewrite everything we have right here. And then we need to divide by the derivative of the inside. So the derivative of 2x is 2. So we divide that by 2. Now if we're looking over here, we rewrite everything. And then we need to divide by the derivative of the inside. So we divide by negative 3. Let's put a plus sign there to make it look a little bit better. Okay, 2 over 2, that just gives me e to the 2x, because those cancel. These negatives cancel, and so I can write that as 1/3 e to the negative 3x, and since that's simplified, I just add my plus c, and then I'm done. Alright, we have 2 sine 3x. We're asked to plus cosine of 4x plus pi, and we're asked to integrate with respect to x, and so we add those pieces. Alright, now the so we're going to bring down our 2 because it's constant. Now the antiderivative of sine is negative cosine, so we get negative cosine 3x, and then we're going to divide by the derivative of the inside, so we divide everything by 3. Now the antiderivative of cosine is positive sine, so we get sine, rewrite the inside, and then we want to divide everything by the derivative of the inside. Okay, so if I clean that up a little bit. I get negative 2/3 cosine 3x plus 1/4 sine of 4x plus pi. And since that's simplified, now I can add my plus c. Okay, we have a couple more examples. So now it says to integrate this thing. So the first thing is put the integration sign and the dx. And what we want to do is before we integrate, we're going to think of it like this. And we're going to distribute. So we get 4 minus 2 sine x minus 2 sine x plus sine squared x. Combine like terms. Okay. Put my dx back in there and my integration symbol. And what we're going to do is we're going to use I'll write it down, but we're going to use this fact. Sine squared theta is equal to 1/2 minus 1/2 cosine 2 theta. So I'm going to replace that with that. So we get 1/2 minus 1/2 cosine of 2x. And then we still have the other pieces. So I'll just write those. And then we still have our dx and our integration sign. Okay, so I'm going to move that down to there. So that was just using a trig identity. Now we just need to integrate or take the antiderivative of all of this stuff. I could think of 4 as 8 halves. And if I add that, this and this become 9 halves. Okay, so now if we integrate, that's going to be 9 halves x. And then this piece, I bring down my negative 4. And then the antiderivative of sine is negative cosine. Okay, that was gone. Bring down my negative 1/2. The antiderivative of cosine is just sine. And then we have to divide by the derivative of the inside. So that's going to put another 1/2 out in front. Then we just need to clean this up. Okay, so 9 halves x looks good. And then negative 4 and negative, that's going to make a positive 4 cosine x. And then this is going to be negative 1/4 sine 2x. And that looks pretty good. So we just put our plus c on the end. And that's our final answer. Okay, now we just have 2 more. 1/5x minus 3 dx and 4/1 minus 2x dx. Okay, so we'll do both these. The trick on this one is remembering that the derivative of natural log of x is 1/x. And so when we do this one, we're just going to treat it like this is an x first. So we say natural log absolute value of 5x minus 3. But then we need to divide everything by the derivative of the inside, which is just 5. So we can put a 1/5 out in front, and then we say plus c, and we're done. Okay, this is going to be similar, but we're going to say 4 natural log absolute value of 1 minus 2x, and then divide that by the derivative of the inside, which is -2. And so we end up with -2 natural log of the absolute value of 1 minus 2x. And since we're done, we tack on our plus c, and that's everything. If you need additional help, please come to Math Lab. Until then, calculate.